Structural engineering, like any other domain, is also witnessing some emerging areas. So here are few upcoming fields that you should focus upon to upskill if you are a structural engineering professional. The very first in the list is computational design. Nowadays, it has become critical that you automate the repetitive design task and use an algorithmic approach to solve complex design problems, which need multiple iterations. The major advancement that has been made in these areas are Grasshopper integration with the analytical softwares like ETABS, FEM Grasshopper basically is a visual programming tool that is used to create small scripts and which can be further linked with the analytical softwares like ETABS, Autodesk Robot, FEM to automate the complex or repetitive design tasks which are there. Similarly, ETABS API development using Python is also being used nowadays, which is the code or the script is being developed on Python to do automative task in ETABS. Similar integration is there for FEM design. So if you want to upskill in this domain, learning Grasshopper, Dynamo, Python can be certainly helpful. Further, it is needed that you change your mindset from computationally solving a problem to solving the problems in a recursive way. The next is sustainability and sustainable design. Bygones are the times when material optimization used to be the only focus. Now it is essential that the design is done keeping a view on sustainability parameters. As a structural engineer, the contribution towards sustainability is more during the construction phase than the service life of the structure. The hottest topics in the domains are embodied carbon calculations. So as a structural engineer, you should be aware how much carbon consumption has been done for the erection of the structure that is there or the design that you have proposed. The next point is life cycle assessment. Life cycle assessment means computing the environmental impacts of a project right from the concept stage to the ending stage of the project. There are multiple tools available to compute the LCA of a particular building. The next point is circular economy. To implement circular economy in your project, you should be looking for recyclability and reusability of structural material within your project. How it can be used as the same capacity material or a structurally degraded material. The third point is advanced materials like precast concrete. The use of precast structures has been much prevalent now than any other time, as it offers multiple advantages over conventional cast in situ buildings. Precast structures offers multiple advantages as compared to conventional cast in situ buildings. Reduced construction time, improved construction qualities are some of those. Further, connections are much more critical when it comes to precast structures, since all of the connections are non-monolithic and are being done at site. Further, it is needed in precast structure, the skilled labor and the skilled structural engineers are required to work on the design part. Similar to precast structures, structural timber is another material which is getting prominence in the industry. Earlier, timber as a structural material was mostly used in small houses. Now it has been adopted in higher story structure as well. There are multiple advantages for timber as a structural material. Timber has a low carbon footprint. Earlier, it mostly used for small house dwellings or houses. Now it has been used for medium or high-rise structures as well. Glue lamps, CLT panels are some form of structural timber which are used. Glue lamps are nothing but the glue laminated beams, columns which are used as a structural member. CLT panels are the cross laminated timber panels which are used as members or shear wall members in the structure. Further, timber also is a very complicated structural material as it is orthotropic and it needs skilled structural engineers to work upon. The next point on the list is performance based design. PBD is a displacement based design which is an alternate to conventional force based design method to attain optimized result. Performance based design gives optimized design results as compared to force based design. What you are essentially doing that rather than checking the force or the stresses in a material, you are actually checking the displacement and the strain level and you are controlling them. Here you can see that for every critical joint in the building, the displacement levels are monitored and if they are attained at a certain level, building are classified accordingly. So building can be either operational or life safety or collapse prevention. The last point on the list is structural topology optimization. The jagged facades that you see in the new age structures are mostly designed using this, wherein you find the optimal shape and pattern of the structure based upon the material stresses. To dwell more on structural topology optimization, it is technique to find optimal structural configuration based on stresses. So you are essentially focusing that which part of the structure or which part of the body is more stressed and you're putting more material there. It gives optimal solution with less material for a lightweight structure. Basically, FE analysis along with optimized algorithms are used to achieve this.